Hi, algebra class. We are doing a new lesson. First bullet point says an exponential function has the form y equals ab to the power of x, where a is not 0 and b is a positive number bigger than 1. Right, if a is greater than 0 and b is greater than 1, you can probably hear Otis barking, then this is an exponential growth function. So it gets bigger and bigger. And b is called the growth factor, so it determines how quickly it grows. Sorry, Otis is barking at the pool man. Alright, this chart shows you the parent function. So what that means is the most basic form of this function, y equals b to the power of x. And it shows you that it hits at the points 0, 1, and 1b. So b is that base in the formula. And then it gives you a new term called an asymptote. And that means that the graph is going to get really, really close to that line that I just outlined in purple, but it is never going to touch it. Alright, so we're going to graph y to the 2x, and I always choose x's values to be 0 and 1 because those are the easiest to work with. So y equals 2 to the 0 power, so I'm just plugging into the formula to find the y value. And I end up with the points 0, 1, and 1, 2. And again, you're always going to have that asymptote, and until later, we'll find one more point. So the point 2, 4. Then until later, that asymptote is not going to change, so just always make it the x-axis until later. Alright, and then we'll graph with those 3 points. So again, I chose the points 0, 1, and 2 for x because they're right in the middle of the graph and they're the easiest to plug in to find your y values. So we're going to do the exact same thing for number 2. And plug in 0, 1, and 2 into y equals 5 to the power of x. I didn't say this in the last one, but if you remember, anything to the power of 0 is 1. Just a reminder. Alright, y equaling 25 is obviously not going to fit on our graph, so I'm not going to put it. But you can put 0, 1, and 1, 5. There's that asymptote. So all the graphs have the same basic shape. Alright, this next bullet says the graph of a function y equals a times b to the x is a vertical stretch or shrink of the graph. Right, so instead of hitting at 0, 1, now it's going to hit at 0a because we've introduced a new number. Alright, all the vertical stretch or shrink means is that it's either going to grow faster, so it's going to go up faster, or maybe it's going to grow a little slower. With the 1/2 being my new factor, it's actually going to grow slower because this number is cutting it in half. Alright, but we're doing the same things. Remember, with order of operations, to do your exponents first. So on this one, 4 squared is 16 times 1/2 is 8. Alright, again, I have 3 points to put on this graph. And my asymptote is still at 0, or at the x-axis. So I'm going to draw that in and then connect my points with the graph. Beautiful. Alright, we're going to keep doing this. Just plug and chug, plugging in. For x, we're plugging in 0, 1, and 2 into that equation. So y equals 1/3 times 3 to the 0 power. 3 to the 0 is 1, so 1/3 times 1 is 1/3. The next one, 1/3 times 3 to the first, is 1/3 times 3, which is 1. And then 1/3 times 3 squared is going to be 1/3 times 9, which is 3. Again, graphing these points, obviously the fractions don't have to be perfect, just try to get it close. My asymptote is still at the x-axis. So I'm going to draw my graph going in that same shape. Gets really close to that line, but shouldn't touch it. Alright, so these are both shrinks, since the number in front of the exponential factor was a fraction. Right? If it was a whole number, like a 3 or a 2 or a 7, it would end up growing much quicker because it's being multiplied by 7 instead of 1/2 or 1/3. This one is a little different, having a negative. We haven't had that yet. Alright, still 5/2 to the 0 is 1, and then you have a negative, so -1. Alright, 5/2 to the first is 5/2, and then with a negative, it's -5/2. So when I graph these, they're not on the same side of the graph that I'm used to, and they're not going in the same direction. What that negative does is it flips your graph over. So I'm actually going to see where my y value is when x is -1. Alright, from last test, you should know that a negative exponent flips your fraction. So you end up with 2/5 instead of 5/2. And that negative is still hanging out there. Alright, so I can see that it's still getting really close to that same asymptote, but it's coming from the bottom instead of the top of the graph. Alright, and then here's another one like that with 7/2 instead of 5/2. So it's going to be really simple, but now I know that about the -1 for my x value. I'm going to go ahead and plug that in and do it in that order. Okey-doke, plot those points. It should look super similar to that graph above with the 5/2. Oh, and if you're wondering where I got the point for 7/2, that's the same as 3.5. So you just, again, estimate, get as close as you can. Alright, now we're going to be changing our asymptote and doing a little bit extra. Alright, so we're going to graph things in the form y equals ab to the power of x minus h plus k. That should remind you of the vertex formula that you all hated back in the day with parabolas, but hopefully it goes better here. So I'm going to shift the graph horizontally by h units and vertically by k units, and we'll do practice. And we're also going to start talking about domain and range. So domain is x values, so what x values are included in the graph. For these, it's always going to be all real numbers. And then the range is going to be what we move it. We'll move it up or we'll move it down with that k. So again, we'll talk about that. Begin by graphing without the new things. So for this first one, begin by graphing y equals 4 times 2 to the power of the same way we have done. And we're only going to use x values of 0 and 1. Make it a little easier. Alright, so 0, 4, and 1, 8. And with this graph, the asymptote is at the x-axis like we're used to. Alright, but now I'm going to use those new numbers. So that means we are shifting to the right. We are shifting to the right 1 unit, and we are going down Sorry, I got a little upset there. Alright, so now we're going to move each of those points right 1, down 3, and plot new points. And this is the graph that I actually want. Alright, but whenever I go down 3, I also need to move that asymptote down 3 units. So this is what my new graph looks like. Last thing, I need to state the domain and range. The domain, as I said earlier, is all real numbers. That'll always be your answer. The range, look at our y values. They start at -3, but they never touch -3, and then they go up from there. So my range is y is greater than -3. Alright, again, we're going to start by graphing what we're used to, so ignore the extra numbers. And then I made a mistake. That little 2 should be an exponent as well. It should be x plus 2 in the exponents. Alright, and graph the points when x equals 0 and when x equals 1. So plug into that formula. So I have 0, 2, and 1, 6. I have, oops, I forgot my asymptote. I have that at the x-axis, and then I can draw my graph. Alright, and now they need to move left 2 and up 1. So left 2, up 1 for both of those points. Left 2, up 1. My asymptote is also going to move up 1. And there you have it. There's our graph. Alright, last thing, domain and range. The domain is all real numbers. And the range, y is greater than 1 this time. Alright, last one, and then y'all are going to practice on the worksheet or very neatly on notebook paper if you can't access a printer. Alright, remember f of x means the same as y equals, so don't let that freak you out. It means the same thing. So y equals 3 to the x is when I'm going to start off graphing before I shift it. Alright, so I am getting my 2 points when x equals 0 and x equals 1. So I'll plot 0, 1, and 1, 3. I need my asymptote at the x-axis and draw my graph. Alright, I decided to do an extra point because I knew it would fit on the graph with 3 squared being 9. But you don't, again, you only have to use x equals 0 and 1. But it works with any point. So the next thing, I'm going to shift it left 1 and up 2. So every point gets shifted left 1 unit, up 2 units. And then my asymptote gets shifted 2 units up. And then I'll draw my graph through those points. Last part, domain and range. Domain, of course, is all real numbers. You should know the drill by now. And the range, y is greater than 2. Great job.